Little ding. Okay, the last lecture I always give, I like to call Ecology for Business Majors, because we've been talking about the living world and everything that's in it. And being a biologist, I find it fascinating and wondrous and amazing and worthy of preserving as much of it as we still can. Not everybody who takes this class shares my views. And in fact, students in business are more likely to have the attitude of, well, all of this tree hugging stuff doesn't really affect me because I'm going to go out and get a job. Yeah, I don't believe it either. But the kind of things that we've talked about in this course are not the sorts of things that everybody values. And I always like to start by talking about endangered species, because this is something that everybody has heard of, is that there are some species that are at risk of going extinct if humans don't take action to keep them from going extinct. And this raises the question as to why we should care. Just for fun, think about which animal might be most worth saving. This is an endangered species that is adorably cute and fluffy. This is, of course, Aeluropoda melanoluca, the giant panda, restricted to a small part of China and still at risk of extinction, and used as kind of a global icon for species conservation. So think for a minute about which one you like better, the adorably cute and fluffy panda, or this slimy, hideous, and disgusting sea slug, Dolabella auricularia. Which one is more worth saving? Now, when I ask this question in lecture, everybody, we've been together for 15 weeks, and so everybody pretty much knows it's a trap because me. But most students probably feel more warm and cuddly towards the panda than the Dolabella sea slug. And here's the reason why maybe that appearances can be deceiving. Dolabella is poisonous if you eat it, which makes sense because Dolabella is soft and squishy in a world full of predators, and organisms that can't fight off predators or run away often are poisonous, as are many plants, of course. Beginning in the 1980s, people investigating chemistry found some compounds in Dolabella called dolastatins that have the effect of blocking mitosis, cell division, remember that, by screwing with the spindle fibers. There's a modified version of one of these dolastatins. It's sold under the trade name Adcetris. The full name is brentuximab vedotin. And it's currently being used to treat Hodgkin's lymphoma, type of cancer, and certain other types of lymphoma. There are other dolastatins that are being investigated. So we've got a cutting-edge anti-cancer agent derived from a disgusting, slimy, squishy sea slug. And it should make you wonder what else you might find in the other 4,000-odd species of sea slug that are out there. Species are sometimes very much worth conserving from a purely human point of view because of benefits that we directly get from them. I finally have a chance to show you, by the way, a noteworthy scientist of color. A lot of the pioneers that we've talked about, everybody from Darwin all the way to Watson and Crick, were white males, and there's nothing wrong with that. I mean, I am one, but they worked in a time when women and minorities simply didn't have the opportunities that they do. This is not changing fast enough, but it is changing. And trust me, we've got enough scientific problems that need urgent solutions that we can no longer afford to reject the brains of more than half of the world just because it happens not to come in white skin with male genitalia. And, people of non-European backgrounds are certainly capable of making major contributions. And here's one of them, Percy Julian, who worked out ways to extract certain compounds from plants, including soybeans, and also including this weird thing on the left with a great big scaly root called Mexican yam, Dioscorea barbata. And it turns out that you can extract compounds from those plants and convert them into steroid hormones. And Julian figured out how to do that. And it's his work that made possible, well, for one thing, birth control pills. If you're not a fan of that, it also made steroid hormone shots possible. If you've ever gotten a cortisone shot, cortisone is a steroid hormone, and yours was probably extracted, made from compounds extracted from soybeans, in part due to Percy Julian's work. And our history of extracting medicines from plants goes all the way back to, I think, every human society, no matter how, quote, primitive, has used medicinal plants. Certainly Native Americans did, Europeans did, everybody did. Aspirin was originally isolated from willow tree bark. There's a plant, there's a lot of it in the desert southwest of the United States called joint fir. There's a chemical in joint fir that can be made synthetically and sold under the name Sudafed, pseudoephedrine. So everything from cutting-edge chemo treatments to over-the-counter medications to steroid hormones and birth control pills were originally derived from plants. One of the Nobel Prize winners in medicine in 2015 was a Chinese researcher named Tu Youyou, who developed a drug from a plant called sweet wormwood, Artemisia annua. It turns out to be effective against malaria. It is currently, I think, the frontline treatment. You may not worry about malaria in your daily life very much, but it used to kill up to 1 million people a year globally, most of them children under 5. Countless lives have been saved since at least, I think, the 80s by the introduction of artemisinin, and it's derived from a plant. The other Nobel winners in 2015, Campbell and Omura, developed an entire family of anti-parasite drugs from a soil bacterium called Streptomyces. This is what it looks like. It's a weird bacterium because it tends to grow in filaments because it thinks it's a fungus. Don't worry about that. I promise you that is a prokaryote that you're looking at on the right, that stuff that looks like rotini noodles. This species of bacteria makes an entire family of drugs that turn out to be effective against parasites. The most famous one's called ivermectin. Every veterinarian uses it to treat everything from dogs to horses. It can even be used to treat human parasites, including the parasite that causes diseases like African river blindness. So, you know, the lives of millions of people have been made better by the discovery of ivermectins that are made by, in this case, a soil bacterium. There could be these things growing by the millions under your feet, and you might never even know. Okay, so we get lots of medicines out of plants, but maybe you don't care about drugs. We get food products from plants, and I don't just mean the obvious ones like, you know, corn and tomatoes and potatoes and wheat and all of that. We periodically find plants that we can bring to market in the form of new products. This is a South American shrub called stevia. You can make an extract of its leaves that's 300 times sweeter than sugar and doesn't have any calories. And you can buy this stuff in the grocery store as a sugar substitute under brand names like Truvia and Purevia. Okay, valuable product produced by an obscure South American shrub. Here's one that created jobs directly. The plant on the left is called Ilex guayusa. It's found in the Amazon basin of South America. And what's cool about it is that its leaves are rich in caffeine. And you can use its leaves to make a very pleasant tasting tea. And there's a company, the founder actually came and gave a talk at UCA about 8 years ago, which is how I found out about this. A company called Runa that buys guayusa leaves from small farmers in Ecuador, and they can harvest these leaves sustainably. You hear sustainable thrown around a lot, but it basically means we can keep doing this, right? A sustainable practice is something you can keep doing year after year. And you can pick leaves off of guayusa plants without destroying the entire plant. Something like 20,000 Ecuadorian small farmers get some money by selling the leaves to the Runa company. And the Runa company turns them into a line of teas and energy drinks. I haven't seen them very much in Arkansas, but my local Kroger actually stocked some a while back, and I tried some, and they're actually pretty good. Tastes kind of like the missing link between tea and coffee. And it's currently a thriving small business. It's got something like 300 employees in the United States, and it's boosting the economy of Ecuador. So this is a plant that's worth keeping around because we get direct benefits from it. I'll give you another one. Those are spores of a soil fungus called Pestalotiopsis microspora. And it was found in 2011 that Pestalotiopsis microspora can break down plastic, specifically a plastic called polyurethane, which you would know because it's what things like skateboard wheels tend to be made of. It's also used a lot in foam insulation. One of the problems the world faces is we're loaded with plastic garbage. And now that we have fungi with the capability of breaking down that garbage, they may end up providing the solution. There's even talk of trying to convert plastics into edible protein by using them to grow fungi like this. So a major pollution problem, reason for, filling up of landfills and things like that may turn out to be solvable by using the capabilities of wild species like Pestalotiopsis, which again is present in soil everywhere and you might not even know that it's there. There's even species that are coming to be useful as sources of fuel. This is a little weed called camelina. It produces oily seeds, and it also grows in poor soil. So you don't have to decide, am I going to grow corn or grow camelina? You can grow camelina on land where you couldn't grow anything else. The oil turns out to be usable as a biodiesel fuel, and the Air Force has been testing a 50-50 blend of standard aviation fuel, what they call JP8, mixed with camelina. In September 2011, the Blue Angels flew successfully using camelina. Is that useful? Well, bear in mind that the military uses enormous amounts of oil and gasoline. Large amounts of the world's supply of oil and gasoline is under the soil of countries that may or may not like us all that much. And it would be very useful from a military point of view to be able to tap into sources of oil that don't have that problem. That's kind of fallen on the back burner because the US has been able to boost its own oil production. That is not going to last forever. It's starting to slow down now. And in a future conflict, it may end up being very useful if we have a source of fuel for our airplanes, not just military, but civilian too, that can fly on plant-based oil, which is renewable. You can plant it year after year instead of relying on oil that you have to extract from the ground, which you can't indefinitely keep pumping out. So the bottom line is, what is all of this biodiversity worth? What good do all of these species, most of which we'll never even see, what good is it to have 1.8 million known species of animal and plant on the earth? What has biology ever done for us? Well, what it's done is we know of hundreds of thousands of compounds that animals, plants, and protists and fungi and bacteria produce. We discover at least hundreds each year. Many of them turn out to have useful properties as drugs. Or else, if they're not useful themselves, they've led to the development of new drugs. Many drugs that are now made artificially were first discovered in plants and animals. Willow bark contains a compound called salicylic acid, which turns out to be very good in relieving headaches, right? Well, a German chemist found out how to make salicylic acid artificially, or make a modified version of it called acetyl salicylic acid that does the same thing and is less harsh on your stomach, and called it aspirin. But he'd never have discovered aspirin if he hadn't started by looking at the compounds in willow bark. Something like a quarter of all US prescriptions are written for drugs that either are derived from plants or are based on plant products. And we constantly find new drugs that we can discover and test. There's other chemicals we can use as sources of food, sources of fuel, dyes, sources of consumer products like rubber, for example. And then living things provide more indirect services. Here's a bunch of bats flying over a field. One little Mexican free-tailed bat, Tadarida brasilensis, can eat an insect every 10 seconds all night long. Multiply that by the fact that I think the largest known bat colony consists of 2 million bats. So imagine a flock of bats eating 2 million insects every 10 seconds for the length of an entire night, and you see the effect that bats can have. Insect-eating bats save the U.S. agricultural industry at least $3 billion each year, quite possibly more than that, because if they eat plant-eating insects, those are insects that the farmer no longer has to spray pesticide on or accept the loss of his crop, right? Insects can't eat your crops if the bats are eating the insects. So they save at least $3 billion each year in U.S. agriculture. We talked about pollination Monday. Animals that fly from flower to flower and transfer pollen. Honeybees are famous as pollinators. And these are some honeybee hives that are getting trucked into an apple orchard. The hives will be set out. The bees will fly from apple flower to apple flower, transfer pollen, and enable each apple flower to produce a fruit. You don't get any fruit if you don't have pollinators. We depend on honeybees, well, on pollinators, mostly honeybees in this country, for nearly a third of our food supply. All of your berries, most of your fruits, everything from avocados to apples to citrus to melons, to all of your berry crops, blackberry and blueberry and whatnot. Tomatoes, peppers, cotton. Okay, you don't eat that, but it's certainly necessary. Almonds are a big one. And clover and alfalfa, which you don't eat, but which we feed to livestock. All of those would not reproduce if they didn't have pollination, mostly by honeybees. So bees add at least $15 billion to the value of U.S. agriculture. Some of that is, of course, the honey that they make, but most of that is in pollination. There are businesses that will truck thousands of honeybee hives from farm to farm, setting them out and letting them pollinate, because you won't have a crop if you don't have that. So I hope you see that preserving biodiversity is very good business. And again, this is the lecture. This is the business lecture This is the, environmental conservation for Ayn Rand lecture. This picture shows a baby California condor. That was an endangered species in the 70s. They were almost wiped out. The last of the condors were trapped and taken out of the wild in the 70s, and the species was kept going by a captive breeding program. That baby condor is taking meat from, that's actually a hand puppet on the left. It's being fed by hand. This was some rather intense effort to try to save the last of the condors and enable them to come back to the wild and grow in their natural habitat once again. So we can save single species like that, but you can't really do that because there's no species of any living thing that's truly isolated. If there's one thing that ecology should teach you, it's that. Every species depends on its ecosystem. The food that it eats, the symbionts that it lives with, even its predators may actually keep that population from overgrowing its resources and keep it, help to propagate it in the long run. Everything depends on everything else. I can't remember which poet said it, but someone said, "Thou canst not stir a flower without troubling of a star." Maybe stars is a bit much, but it's true in ecology. You can't affect one species without finding that it's connected to everything else. So if you want to save California condors, you have to protect the ecosystems that they live in. So I'll give you another choice. Here's a beautiful ecosystem in the Ozark Mountains with adorable and delicious furry animals and lovely trees and shrubs and majestic scenic views, compared to a mucky, nasty, slimy, stinky, mosquito-infested coastal salt marsh. Which one should we preserve? You probably would rather be in the Ozarks than in the salt marsh, and I don't blame you for that. Certainly, coastal salt marsh is not as attractive as the Ozark Highlands. But the salt marsh in Louisiana, in the Gulf of Mexico, provides about a sixth of the U.S. seafood catch. People harvest furs and hunt ducks and fish and do recreation there, including my dad, who goes fishing down there every chance he gets. More important, economically, they serve as a blockage against hurricane damage. Waves coming off the Gulf of Mexico get blocked by having to pass through those salt marshes before they can hit dry land. Part of why Hurricane Katrina in 2005 was so hard on New Orleans is there used to be about 50 miles of marsh and swamp between New Orleans and the open ocean. Most of it's not there anymore. So storm waves could break much closer to the city because there's no longer that barricade. The value of all U.S. wetlands for storm protection has been estimated at over $20 billion a year. That's not so much money that you put in someone's pocket, but it's money that you don't have to spend on rebuilding, that you don't have to spend on coastal defenses like seawalls and things like that, money that you don't have to pay out in insurance claims, comes to the figure of $23.2 billion a year that U.S. wetlands save the economy. They even purify water. That's a wetland built by a city outside of Savannah, Georgia, called Richmond Hill, that basically just diverts its sewage into these wetlands. What happens is that the sewage is broken down by microbes, bacteria and things like that. Plants also absorb compounds in the sewage, like, nitrogen and phosphorus and things like that. And by diverting their sewage into these wetlands that they built, they can treat over 1 million gallons of wastewater a day at a cost of about 10% of a traditional sewage treatment plant. It doesn't work everywhere, but it can work very well by building an ecosystem that can deal with the problem of sewage disposal. That's why it's a bit disturbing that the US has lost over half its wetlands since 1900. Louisiana, in particular, has lost 2,000 square miles in about 80 years. That works out to roughly one football field an hour. A lot of what's marked on land in the map on the left isn't really land, it's wetlands, and we are losing it. So there might be a pretty good economic reason for preserving US wetlands. Maybe. Maybe you don't care for wetlands. Here's a coral reef. If you want to go dive on a coral reef, you probably ought to go in the next few years. They're critically endangered ecosystems, partly from human damage, partly due to climate change. Who gives a bleep? If you could preserve all of the world's coral reefs as they are, they generate almost $6 billion worth of seafood. You know, coral reefs include species that people can eat and that you can harvest sustainably, which just means you can keep doing it from one year to the next. You'd get $9 billion per year in coastal protection because coral reefs can protect coastlines from storm damage. So that's $9 billion that doesn't have to be paid out in, insurance premiums. $9.5 billion each year from tourism. Lots of people like to dive on coral reefs and go fishing and things like that. That's big business. And then $5.5 billion per year from the future development of drugs like that anti-cancer agent coming from a sea slug. So those are estimates from 2003. That's the latest that I could find. So preserving coral reefs would generate enormous amounts of economic activity. I don't say this a lot, but I'm glad that George W. Bush actually declared a lot of small islands that the US holds title to as part of a marine national monument. It used to be called the Northwest Hawaiian Islands National Monument, but the US is actually preserving a lot of the coral reefs that we have on our territory. Trying to protect them, trying to keep them going. And this is why. There are direct economic benefits from doing that. Probably the single most important ecosystem that humans need is soil. You can't grow plants without the stuff, or you can, but it's expensive. And soil has been called the poor man's rainforest because it's so rich in bacteria and fungi and plants and protists and roundworms and earthworms and ants and beetles and snails and slugs. Oh my. All of those organisms maintain soil structure and soil fertility. We don't really understand soil all that well, and yet virtually all of your food is grown in soil. And topsoil, once you lose it, takes a very long time to get back. And there are parts of the world where topsoil is eroding rapidly. So can we put a dollar value on all of this? I don't like having to put dollar values on this because I'm a tree-hugging hippie. You might have noticed the hair, who just generally believes that, we ought to preserve nature because it's cool, man. But a guy named Robert Costanza, back, 23 years ago, tried to put a price tag on everything that the living world puts on our plates. Everything that the living world gives us. Everything from food to the value of soil to the value of the oxygen that you breathe, which comes from plants, to the value of recreation and the value of insurance that you don't have to pay out. Try to come up with estimates for all of the goods and services that the biosphere, the living world, provides to humanity for free. In 1997, the total gross domestic product of the world, the value of everything that everybody makes, and sells and gets paid for was $18 trillion. That's in 1997 dollars. I'm sure with inflation it would be more now. The estimated annual value of all of the goods and services that the environment gives us free, all of what Karl Marx called the free gifts of nature, was at least 33 trillion and possibly 56 trillion dollars, maybe even more than that. So the total value of the living world, the biosphere, is somewhere between 2 and 3 times the total value of the world's economy. The living, all that stuff that they study over in the College of Business, the living world is 2 to 3 times more valuable than that. There's a price tag on what we've been studying. Costanza and Company put out another study in 2002. If you could invest $45 billion, that's a lot, but, countries like the United States do in fact have that kind of money. And if you could invest it in preserving large tracts of what's left of wild land and wild ocean, you'd get 100-to-1 return on investment, because you would get between 4.4 and 5.2 trillion dollars worth of benefits. The benefits include sources of food, new products, new drugs, new other things like that, clean air, clean water, all of these things that healthy ecosystems can provide. You'd get 100-to-1 on your investment. You're not going to get that anywhere else. The stock market is not performing anywhere like that. So why isn't every big corporation preserving every last scrap of wilderness? Well, the reason is that the benefits of conservation, many of them are what economists call public goods. Take clean air, for example. Nobody has yet figured out a way to attach a meter to your nose and make you pay for every breath, right? The air is free. Nobody pays for it. And if we have clean air, you benefit from that, from not getting asthma or other lung diseases or things like that, regardless of whether anybody pays for them. This is what we call a public good. If a factory cleans up its exhaust and makes the air cleaner, everyone benefits, even if those people are not doing anything for the factory in return. The opposite of this is a private good, which benefits only the person who buys it, right? If you buy a cheeseburger and you eat it, right, you gave your money to McDonald's, you got the cheeseburger, you ate it, you're the only person that benefits from the cheeseburger. That's a private good. Most of the benefits of conservation turn out to be public goods, which means that they don't necessarily result in money in anybody's actual pocket. So think about somebody who clear cuts rainforest for timber, chops down a whole bunch of truffula trees and drives out the singing barbaloots and the humming fish and makes a lot of money. Well, the person who cuts it down gets to keep his profits, right? Gets to keep his money. What's lost is spread out among everyone in the neighborhood. One person benefits, but everybody in the neighborhood loses because soil erodes. There's more erosion because there's less to keep soil from washing away. You lose animal and plant species. You lose water purification. And all of those are spread out, which raises the question of how bad can this possibly be? And costs like this are paid whether or not anybody chooses to pay them. And those are called externalities. So if we've got, that's some rainforest getting chopped down in Brazil, but let's take it closer to home. There's some big chemical plants on the banks of the Mississippi River between Baton Rouge and New Orleans. They tend to produce a lot of pollution. If you live close to a chemical plant, you're stuck with the pollution, and that's a cost to you because it makes your health worse. It increases your risk of cancer. That stretch of the Mississippi is called Cancer Alley. And you have to pay that cost whether you choose to or not. If you live there, you're stuck with it. It's not a cost that the owners of the factory have to pay for. They get to keep their money, and they don't have to pay the cost of living just downstream from a big chemical plant. And costs like this are called externalities. And when you have a situation like that where the cost of using a resource is shared, but individuals get the benefit, what your basic capitalist theory predicts is that individuals will maximize use of the resource. That sets up a situation called the tragedy of the commons. Commons is an old word for grazing land that would be owned by everybody in a village, and anybody in the village could use to graze their sheep. So the village owns the land, individuals own the sheep, and individuals, can make money by selling the sheep milk, meat, or wool, whatever they want to do. Let's say there's only enough grass for 100 sheep. Let's say we've got 10 farmers, each of which has 10 sheep, and they're grazing on enough land for 100 sheep. And one farmer says, okay, I want to add one more sheep. That farmer keeps the profit from growing an extra sheep. The damage caused by overgrazing, because there's now just one more sheep than you can really support on this land, that gets spread out to everybody. Everybody's sheep get a tiny bit less food, and the one guy with the extra sheep gets the profit of selling the wool. And then the other farmer says, hey, I want to do that. So the second farmer adds a sheep, and then the third one does, and then the fourth one does. Every farmer tries to add more sheep. Ultimately, the grazing land is completely overgrazed, and there's no more grass, and there's no more good soil, and there's no more sheep pasture for anybody. That's the tragedy of the commons. And here's a real-world example of this. This is Atlantic cod, a formerly exceptionally abundant species in the North Atlantic Ocean. It was fished for hundreds of years, ever since the days of the Vikings. It provided a cheap, nutritious, and pretty tasty source of protein. It's the traditional fish for British fish and chips. Well, why am I talking about it in the past tense? Fishermen in northern Canada fished for cod and made money from selling their catch, and used their money to invest in bigger boats, more boats. When technology gave them more things to add, they used their profits to invest in things like refrigerators or freezers, which meant they could freeze their catch on board instead of having to bring it home every day. Sonar units for finding schools of cod. As fishermen invested in better ways of catching fish, that sounds great. You're supposed to invest your profits in growing your business. The problem is here that, especially after the introduction of sonar fish finders in the 50s, the fish catch shot up and then fell back down, and in 1992 it collapsed. We'd gone from 7 million tons of Atlantic cod in the year 1505 to, in 1992, cod stocks went down to 1/3% of that level. Almost all of the cod just got vacuumed clean out of the ocean. More cod were taken than could be sustained, and the population crashed. It didn't go extinct, but only now are we starting to see signs that it's recovering. And an entire way of life, that thousands of people depended on, had to be shut down. There were, thousands of people left out of work in places like Newfoundland and Labrador. Everybody in the fishing industry had done what they say you're supposed to, grown their business, improved their ability to take more and more cod, and that's great up until the point when you can no longer sustain the number of cod that you're taking, and the population crashes down, and all economic activity stops because there's no more bleeping fish. That happened. So things like that are threats to biodiversity. What I hope you've seen is that people directly benefit from having lots of animal and plant species in the world. Even if you never know them, even if you never learn to pronounce their names, even if most of them are bugs and slugs and things that most people don't find cuddly, we benefit from having them around. We need ecosystems. When our political parties talk about conservation, too often the liberals sound like we've got to conserve nature because it's beautiful and fuzzy like a cuddly little white rabbit. And conservatives tend to go, it would be nice if we could conserve this cuddly and fluffy and beautiful white rabbit, but instead we have to beat it in the head because jobs. The truth is that nature is not a cuddly and fluffy white rabbit. Nature is an enormous bear that will knock our heads off if we F with it too much. We are not separate from the ecosystems that drive the natural world. We're a part of them. If they go down, we go down. We have not emancipated ourselves from that truth. We remain a part of nature. If we lose it, we are endangering our own survival. Or as the song went back in 1985, there's a choice we're making, we're saving our own lives. Well, in the past 400 years, the US has lost over 98% of 27 different biomes, everything from prairie to coral reef to coastal salt marsh. This is actually data from before Bolsonaro took office, but even before then, they were losing 20,000 square miles of Amazon rainforest each year. Introduced species can outcompete native life. Everything from kudzu to Japanese honeysuckle and Chinese privet grow faster and outcompete native Arkansas species. You hear about loss of tropical rainforest. Here's some that are getting logged off for timber and for conversion to cropland. But it happens here as well. Up there at the top, that's a biome in California called vernal pools. You have this flat land where pools of water form in the winter and then dry up in the summer. And there's actually life that is adapted to live there. Mass suburb building in California has destroyed something between 60 and 95% of our vernal pools. Who gives a bleep? Maybe, just maybe, there's some random plant or stupid little bug or tiny little fish or something living in those vernal pools that's got a compound that can be made into the drug that will cure the disease you're going to die of. Maybe. Can't say that it will, but it's happened too many times for us to discount the possibility. And when I see ecosystems getting destroyed in mass like that, what it reminds me of is throwing your Christmas presents into the fire because you're chilly. Sure, you can do that, but is that really the best use for them? Global climate change is here, and it's real, and it's going to mess with our biodiversity. Populations are growing, consumption is growing, not just the raw number of people, but the total number of things that they want is growing. And extinction has always happened. You can ask the dinosaurs about that, but we're in the middle of a pulse of extinction where we're losing species possibly as high as 150 a day. There are species that are going extinct, and we're finding them in old collections of, dried insects or something like that, but we can't find them alive now. The species has been lost before we ever got to study it. And unless someone like you Screw this cares a whole awful lot business. Caring is cheap. Unless someone like you gets off your ass and does something, starting with a hard look at your own lifestyle, is what the Lorax would really have said, nothing is going to get better. It's not. Maybe there's still a chance to turn the tide. We'll have to see. And on that downer, but hopefully somewhat hopeful note, I'm going to go ahead and leave you, and I will now stop recording.